Throughout American history, quilters have used transformations to create intricate geometric designs. For example, the quilt at right is an example of a design based on rotation and reflection, while the quilt on the left contains translations, rotations, and reflections. Those are the three types of transformations that we focus on in Integrated 1. So today's essential question for section 314 is, how can I move it? Do you like to move it? Move it. How can I move it? Well, there are three ways to transform things. We're going to talk about those rigid types of transformations, those three. We're also going to talk about slopes of parallel and perpendicular lines and learn a little bit more about that. So again, for this lesson, make sure that you have a few pieces of patty paper ready to go at your table so you can share these. Especially sharing, since some of these shapes, some of these shapes just repeat. So we're going to be able to reuse a lot of these patty papers. So let's begin. All right, here we go. Get ready. Get set. Let's go. Rotations on a grid. Consider what you know about rotation. A motion that turns shape about a point. It's like if you are here and you okay, that was my attempt at a face. Looks more like a nose. But if this is you and you're trying to crack your neck, sometimes people like to rotate their head so they can crack their neck. Does it make any difference if a rotation is clockwise versus counterclockwise? To the right versus to the left? If so, in which situations does it matter? Are there any circumstances in which it does not matter? And are there any situations in which the rotated image lies exactly on the original shape? Of course, we're going to be able to answer some of these questions, or all of these questions, with some patty paper, also known as tracing paper. So have these ready to go. All right, here we go. Be prepared to share your answers on these. I'm going to give you some time to try these out with patty paper. But first, let me show you. Again, this one is clockwise. It's to the right. You can check the arrows. This one is counterclockwise. It's to the left. This one is clockwise. What about this one? Counterclockwise. Look at the way the arrow is facing. Okay. Next one, letter E, it's going clockwise 270 degrees. 360 is clockwise. 180 it says either way, and then 90 it does say either way. All right, so go ahead, try them out, letter A through E. But let's try one together first. How do you use tracing paper? For this purpose, I'm going to use a permanent marker. You can use just your pencil. It works just as well. So my goal is trace as carefully as you can this shape without moving your patty paper, and also include the dot, which is the point of your rotation. Okay, so it should be this one we could be using for letter A and for letter B. All right, I'm not quite there yet. I have traced it. Have you traced it yet? Okay, I traced it. I traced it carefully. It'd be nice if I also added those dots super carefully. The corner dots, those are the ones that really matter the most to do those accurately. But can you add something called, I'll write it right here. Can you add a crosshair? A crosshair is just like a lattice point. Can you add a crosshair that goes through your dot? So for this case, on your patty paper, can you add a T shape? All right, you can do it with a different color. Sometimes I like to do it with a different color there. So add the T shape so that you can easily do your rotations. This one asks us to rotate it 180 degrees. So for 180 degrees, each of these rotations is 90, 90, 90, and 90. So if I need to rotate it 180, of course, I'm going to rotate it not only 190, which should be right there, keeping the dot in the same place that it was. Keep the dot in the same place as it was, but it has to be rotated 180 degrees. Then you're going to carefully trace what that looks like. So move your paper and draw it. Careful to draw it exactly as it should be without changing the shape or length of this figure. All right, and that would be 180 degrees clockwise. What about 180 degrees counterclockwise? So counterclockwise, of course, just means move it or rotate it to the left. 90 is one turn. 180 is another turn. What do you notice? It's the same exact position as going clockwise. So, of course, you're going to notice things as you do this activity. So go ahead and complete letters C, D, E, F, G, and H, being ready to share your answers. So if you need a little help, I'll go ahead and show letter C. But yeah, your first step is to trace the shape using patty paper carefully. And also add the dot. What do you do on that dot? Right, you must add. It helps a lot to add a crosshair. 2 perpendicular lines that you can easily show your rotations. All right. Try letter C through H during this time. This is where we're going to pause the video. All right, let's check our work for letter C through H. So letter C, let's just check if we did it correctly, if we got the same answers. If we did, that's wonderful. So for letter C, 90 degrees clockwise should have just looked something like this. All right, I'm going to go ahead and trace that. What's that going to be? You're going to have to draw the shape really carefully as to not change the shape of this graph, of this figure. So just double check, did you do it the same way that it's done over here? It shouldn't change the shape of this kite looking figure. It should be the same, just rotated 90 degrees. Okay, what if it was 90 degrees counterclockwise? Right, if it's counterclockwise, it's to the left. Let's check if you did that correctly. The dot should be here, should be 3 wide. Up 1 over 1 there, and then back to the start. Good job if you got letter D. Now let's check letter E, 270 degrees clockwise. So 270 is going to be 90, 180, and 270, doing 3 turns of this. What do we notice? All right, if you notice so far, letter E looks, doesn't it look exactly the same as letter D? Yeah, letter E and letter D are the same. Why is this that letter E and letter D are the same? Right, it's because one's turning clockwise only 90 degrees, sorry, counterclockwise, while this one is turning 270 degrees to the right, clockwise. Okay, what about letter F? I know you checked out letter F. It says to rotate it 360, so 90, 180, 270, and 360. What happens? Yeah, the shapes should stay in the same position. 360 degrees does nothing. All right, what about letter G? Letter G. Hopefully you got your patty paper, traced it super carefully. Your tracing paper. Added the dot. Did you add the crosshair? Right, the crosshair tends to help it make sure it's perfectly vertical and horizontal, just so you can do the rotations really easy. So if you rotate it 180, that's 290s. And what happens? Yeah, if you rotate the letter N 180 degrees, it will be in the same shape. Okay, and finally, of course, you know this one. If you ever rotate a square, if you rotate a square 45 degrees, it will look like this, but if you rotate it 90, it will still be in the same position. All right, just a little bit of an introduction to using patty paper with figures like this. You can do the same thing on your test. All right, let's flip our paper. Let's check out problem number 327. All right, problem 327 says this. So what exactly is a rotation? If a figure is rotated, how can you describe it? Investigate these questions below. It says graph the point A, which is 4, 1, and B, 2, 5. 1, 2, 3, 4, 5. Then use tracing paper to rotate the 2 points 90 degrees counterclockwise about the origin. Okay, what that means is we're going to need another piece of tracing paper to trace points A and B. When we trace it, it'll become A prime. When we rotate it, it will be A prime and B prime. So follow along. Did you add the crosshair? Add the crosshair. Trace those points very carefully onto your patty paper. And then it says to rotate it. Well, how do we rotate it? 90 degrees counterclockwise. So check this out. 90 degrees to the left. What happens when we do that? We get some new coordinates. Trace exactly where those coordinates are. Here's A prime. And where's B prime? Make sure I do this very carefully. -5, 2. All right. And it says to label the origins the letter O. So add that. Very good. Okay, so far it should look something like this. Now letter B says draw line segments that connect A to O. Okay, A to O, just draw a line. Boom, done, got it. Check. Draw a line segment from B to O. B to O, okay. B to O, got it. Draw a line segment from A prime to O. Okay, A prime to O. And B prime to O. B prime to O. Nice. It says using tracing paper, compare the lengths and angles formed by these line segments. Which lengths are equal? Which angle measures are equal? All right, from A to B, is it the same as B prime to A prime? Very good. We should notice that those two segments are the same. Those two lengths are the same. What about from O to A? Let's see, from O to A and O to A prime. Those are the same. What about O to B and O to B prime? Those are the same. And any angles the same? See, so this question just allows you some time to see if you have any angles the same. So in angles, when you connect 3 dots, is that angle the same as this angle? Yeah, of course. So check it out. That's going to show that a lot of angles are the same. One specific angle we can show is angle AOB. This angle AOB, is the same as angle A prime O B prime. This angle right there. Complicated stuff, but there's a lot of angles and sides that are the same. So another one was AB. Line segment AB, we can put it like that, is the same length as A prime B prime with a bar on top. Just some practice with some things that are quite important for later. All right, let's move on to problem number 328. Problem 328 says the diagram at right shows triangle PQR. Okay, PQR is this one right here. Got it. Boom, boom, boom. Okay, reflected across the line L. Oh, wow. Reflected across the line L to give us triangle P prime, Q prime, R prime. This triangle right there, the ones with the prime on it. It says use your ruler to draw 3 dashed line segments from P to P prime. This can be done without a ruler. Just draw it super straight. Q to Q prime. Draw it super straight. And also a line from R to R prime. And it says, what is the relationship between these line segments? The 3 lines that I just drew, what is their relationship? We talked about this recently. What do you see when you see P, P prime, Q, Q prime, and R, R prime? All these lines are, yes, all of these are parallel. So we're going to go ahead and write that down as parallel. Remember that? We talked about that. The 2 L's in parallel are just, even those 2 L's are parallel. Those lines appear to be crossing like that. They appear to have the same slope. All right, letter B. Now focus only on R, R prime. R, R prime, where's that at? Okay, R, R prime. Okay, that's our focus. Ooh, this one says, what is the relationship between R, R prime and the line of reflection? The line of reflection, line L. What is the relationship between those? So for this one, I'm going to go ahead and highlight these just with a little bit of color. This question, letter B, says, what's the relationship between this line right here, R, R prime, and the line of reflection? As you can see, what's the relationship there? What kind of angle is formed there? It sure looks like it's what type of angle is it? If I look at this, it definitely looks like it is 90 degrees. So what is that relationship? What's another way to say what's going on here? This relationship right here is they are, it starts with a P, perpendicular. All right, letter C now. Letter C says use slope. Oh man, we talked about slopes before. We've talked about slopes to confirm that they're perpendicular. So just a recap of what we talked about recently is to be perpendicular. Actually, let's see. Parallel means same slope. But to be perpendicular, we need to have opposite, reciprocal slopes. Some examples that we went over last time was, if it's 1/2, what's the opposite reciprocal of that? We got to flip over the fraction, and we also have to do the negative version of that, the opposite. So it's -2/1. What's -2 divided by 1? -2. That's an example. Okay. Another example that we went over last time was, for example, 3/7. What's the negative reciprocal or opposite reciprocal of 3/7? Flip it and switch it. That would be perpendicular. One more example. -2/3. How do I flip it and switch it? -2/3. What do I do? Flip it, but also switch it. So we have negative is positive. We get 3/2. So these ones will be these ones will not be parallel. Sorry, these ones will be perpendicular because they're opposite reciprocals. Now letter C says, hey, can you use slope to confirm that the lines are actually perpendicular? So let's carefully figure out what the slopes of these lines are. So line R prime. What's the slope? What's the rise over run? If you look at the rise over run, it's down 1 over 2. Down 1 over 2 is negative 1 over 2. Now what's the slope of the line of reflection, the mirror line? What's the slope? Look, take 2 dots on your line. What's the slope? Rise 2 over 1. Are those opposite reciprocals? Yeah, I can confirm. Yes, they are perpendicular. So the main idea here is if we have 2 over 1 and negative 1 over 2, we know that this is going to form a right angle every single time. Okay, letter D. Place a point N. Well, this is going to be a tough one. Place a point N at the intersection of R prime on the line of reflection. Okay, let's see if we can do that. I need some color here, maybe. Place a point N on R prime where that intersects with the line of reflection. Okay, that means right here. They want us to call it N, point N. Point N, right there. The intersection point. It says, what do you notice about the lengths of Rn, right there, Rn, and Nr prime? What do you notice? So this one, the thing I want you to notice for this one is they're probably the same length. Okay, so you want to write that down. Yes. Well, what do you notice? Not yes. What do you notice is they are the same length. Letter E says, is what you observed for segment RR prime true for any segment connecting a point with its image? That is the line segment connecting a point to its image always perpendicular? Is it always perpendicular if you connect these 2 points to the line of reflection? Is the line of reflection always a midpoint of the segment? The correct answer is yes. The second question answer is yes. Use what you know about rigid transformations to explain your thinking. So, if I took my patty paper, could I confirm these are the same lengths? Look, boom. Could I confirm that these are the same lengths? Boom. Those are the same lengths. And finally, P and P prime. Can I confirm that these are the same lengths? Yeah, they're the same lengths. Why? Because it is a reflection. Every reflection keeps. If it's a really, really decent mirror, it's going to keep all of the distances the same. What's another way to say the same? That's why they call it rigid. Rigid means the lengths and things stay the same. When I rotate something, like my hand, if I rotate it, does the length of my hand stay the same? Yes, because it's a rigid transformation called rotation. Just like rotation is a rigid transformation, we know that reflection is also one, and there's one more called translation. All of these transformations are rigid. All right, let's turn to the next page. All right, that was pretty tough. So now we're going to go ahead and finish lesson 314. Lesson 314 gives us problem 3-41. This is also going to be a bit tough. We're learning some new notation. We're learning B prime, we're learning B double prime, we're learning slopes and a lot of things. So do your best to keep up, and also raise your hand if you have any questions. Here we go. Evan. All right, what's going on with Evan? Evan has graphed the point 5, 7, and he wants to reflect it over the line y equals -2/5 x plus 6. He predicts, hope he's right. He predicts that the reflected point will have a coordinate of 2, 2. Without graphing, can you confirm his answer or show that he cannot be correct? Explain. The diagram is Evan's rough sketch and is not drawn to scale. Hint, think about the relationship between reflected points and what that would mean for the slope. Oh, this is a tough one. All right, I want to give you a couple of minutes to think about this one, and then we're going to go over the answer. So we know two things. This line is y equals -2/5 x plus 6. What's the slope? Boom. Okay. Now we're also given this dot, which is he claims is 5, 7, and this one is 2, 2. It's a really, really rough sketch, but it says, do you think that these two lines, well, do you think it's reflected properly? Think about it, discuss it, think about slope, and let's see if we can come up with the answer before we explain it. All right, so what is the slope of the line? What is the slope of the line? The slope of the line is -2/5. Okay, so that's our goal, -2/5. What do we know about these 2 points? If it was correctly reflected, what must be true about this angle? What's the angle? It's got to be a perfect 90 degrees. We're looking for perpendicular. So if it's perpendicular, we got to have opposite reciprocal slopes. Again, remember this drawing is not to scale. We have to check, are these slopes of the line and the two coordinates connected together, are they perpendicular? So if they are, what's the opposite of reciprocal of -2/5? Positive 5/2. Is the slope between this point and this point 5/2? Let's check. We're going to use the formula y2 minus y1 over x2 minus x1 to see if these have a slope m of 5/2. If they do, then they're perpendicular. Let's see. Without graphing, let's figure it out. So y2 minus y1, okay, 7 minus 2, y minus y, over x minus x, 5 minus 2. 5 minus 2 is going to be, 7 minus 2 is 5. Good. 5 minus 2 is 3. Is this slope an opposite reciprocal? Unfortunately, the answer is no. What would have made it perpendicular? I think it might have been a little bit off. But yeah, that one is not going to be perpendicular. Again, what did we do for this problem? The slope of the line was -2/5. To be perpendicular, we gotta have opposite reciprocal slopes. Were they opposite reciprocals? Well, we looked at these two coordinates, the two dots, and we determined with the formula for slope that they're not opposite reciprocals. It was 5/3 when it should have been 5 over 2, so it was really close. All right, next up, problem number 3-42. All right, 3-42. The formal name for a slide is translation. All right, translation. We practice that a lot. A translation, simply taking a shape and sliding it. All right, let's see. So what exactly is a translation? Remember that translation and transformation are different words. To the right, we have triangle A prime, B prime, C prime. That is the image of triangle ABC. Let's take a little note of that. This is called the image of triangle ABC. We know it's the image because it's reflected. It's got the prime symbols on it. It's not reflected, sorry. It's been what? Translated. Now, letter A says describe the translation. How has it moved? That is, how many units to the right and how many units down did the triangle move? So if we count carefully, let's just check our work here. From B to B prime, how far right did it move? 1, 2, 3, 4, 5, 6, 7. All right. Right 7. And now how many units down did it move? 1, 2, 3. So I'll say down 3. Okay, let's just double check. We want to make sure we wrote this correctly. 1, 2, 3, 4, 5, 6, 7. Yep, right 7 sounds good. What about down 3? Did we do that correctly? Yep, that one's pretty easy. 3 boxes below. Now check if it's true for everything. We just checked B to B prime. What about A to A prime? 1, 2, 3, 4, 5, 6, 7. Okay. What about C to C prime? 1, 2, 3, 4, 5, 6, 7. Good, that matches up. And down 3, does it match up with A and A prime? Yep. What about C and C prime? Yes. So 7, right 7, down 3 is confirmed. So the horizontal movement is right 7. The vertical movement is down 3. Now, our next task is to try this out on paper, just like we're going to be doing on a potential test. It says graph EFG. EFG. Here are our coordinates we have to graph. And I want you to translate it the same way that we did here. We got to go right 7 and down 3. All right, let's see. So 4, 2, 1, 2, 3, 4, 4, 2 is point E. 1, 7, 1, 1, 2, 3, 4, 5, 6, 7. That's point F. G is 2, 0, right there. So connect those dots. I think they want us to connect the dots to triangle, right? Yeah, triangle, EFG. And it says we have to move. We have to move that right 7 and down 3. Uh-oh. Let's see if we can do that correctly. So let's just double check. I want to add the numbers to this just so we can make sure we can see the numbers that are changing here. G was 2, 0. I'll zoom in. G was 2, 0. E was 4, 2. And F was 1, 7. All right. Now, we got to move this right 7. 1, 2, 3, 4, 5, 6, 7, and down 2. What's that coordinate? 8, what is it? 1, 2, 3, 4. 1, 2, 3, 4, 5. That's F prime. What about E? We have to move it right 7. 1, 2, 3, 4, 5, 6, 7, and down 3. Oh, I made a mistake there. So the last one. Sorry about that. It's down 3, not down 2. So for point F, it should have been 1, 2, 3, 4, 5, 6, 7, and down 3. That was F prime. F prime should be at 1, 2, 3, 4, 5, 6, 7, 8, 8, comma 4. What about E? Let's go right 7. 1, 2, 3, 4, 5, 6, 7, and down 3. That should be point E prime. E prime is at the point 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, comma, negative 1. And where is G? G is at 2, comma 0, but we want it to move down 3 and right 7. So right 7, 1, 2, 3, 4, 5, 6, 7, and down 3. You have to do it carefully. You even see I made a mistake. Point G prime would be at the coordinate right 7. I don't know if you've seen this yet, but right 7 just means add 7 to x. Down 3 means subtract 3. Why? Let's double check that for E points. Did we add 7 for x? And did we subtract 3 for y? Let's see. Add 7 for x, we'll get to 9. Subtract 3 for y will get us to negative 3. Now if I connect those dots, look what happens. That shape, if I did it correctly, the shapes should look exactly the same. Yes, so that was right 7, which means add 7 to x, and down 3, which means subtract 3 from y. Kind of complicated, but that would be the answer. So let's answer these questions at the bottom here. It says, what are the 3 transformations that we've studied and what do they look like? So we've had, what are the 3 types? Rotation, which could make a heart turn sideways, if I can draw that correctly, right? We worked on that those rotations with the patty paper back there. We also have done, what's another one? Reflection, which is involving the mirror. It can make any smiley face into sort of a sad face, in a way. Would it make it sad? Let's see. No, it would just turn it upside down. That's a reflection. And there was one more. Translation, which is simply moving a shape like a smiley face to somewhere else. All right, next question. What's the relationship between the slopes of parallel lines? Parallel means same slope. What is the relationship between the slopes of perpendicular lines? Perpendicular, here's the symbol for perpendicular, 90-degree angle, means opposite reciprocal slopes. That's the harder one. Hey, we're almost done. Flip your page. Once you're ready, I'll give you a moment to write that down. The 3 types of transformations, what are they? Rotation, reflection, and translation. Parallel means same slope. And perpendicular means opposite reciprocal slopes. Okay, we're almost done. Last problems here. Okay, so for these ones, I do want you to try these out on your own, and then we'll have a chance to check our work. I'll pause the video here, give you a few minutes to try these out, and then you will be able to check your answers to see if you did it correctly. So for this problem, make sure that you know that you're not only drawing the figure, but you're also going to write the rule. The rule! It's a major thing for our upcoming test. So can you write the rule? Example number 1 is already done for you. Take some time. Answer number 1 through 4. And let's check our work. All right, so let's check our work. So our answer should look something like this. But what is the rule for the translation? Right 5 means x plus 5. Up 1 means y plus 1. remember a couple of things. X is left to right. Y is low to high, or down to up. It's kind of hard to say, but it's going to be left to right for X, and Y is down to up. Or more easily, we have horizontal change, and Y would be the vertical change. So for the first rule, we had X plus 5 since it's right 5, and since it's going up 1, it's going to be Y plus 1. You put that in coordinates just like that, just like you're going to do on your test. Okay, next one, if it's 1 unit left, it's going to be X, not plus 1, it's left, so it's X minus 1. And if it's 2 units up, it's going to be Y plus 2. Don't be confused if it's written in a different order. Left to right is always X. Low to high is always Y. All right, so we'll write down X minus 1 and Y plus 2, and the answer is there if you haven't written it down yet. Okay, translation 3 units down. It should look like this. By the way, did you write down Q prime, L prime, and E prime? To write the prime, it's very important because it shows that it's been moved. It's been transformed. Okay, so the only transformation is going to be 3 units down, which means X stays the same, plus 0, but the Y is being subtracted by 3. So X stays the same. You could say plus 0 if you wanted to, but Y is the one that goes down. So X stays the same, Y goes down by 3 units. Okay, last one here. That was the correct answer. This one, it was 5 units right and 2 units up. 5 units right would be X plus 5, and 2 units up would be Y plus 2, and that would be your answer. Okay, now make sure you have these ones in your notes. Make sure you don't forget all the primes whenever you do the image of the reflection, rotation, or transformation, translation in this case. And finally, be prepared on your test to write rules for translations. So translation is all about left to right, up and down. And make sure you can write rules just like this. I'll give you this time now to ask for help from your teacher. If you have any questions, please reach out. And that wraps it up.